begin his presentation. All right, Carlo, whenever you're ready. Hi, Carlo, can you hear me? Okay,
And
good. Yes, let's
uh,
go.
the purpose of this project is, yes, can you hear me?
I can hear you. Yeah, you can go ahead.
Can you hear me?
Yes.
Okay. Okay. So the purpose of this project is to build a ROS framework that allow this robot, the fastbot, to follow the wall and it on its right. And
Mm-hmm.
also there are three main there are three nodes in a service and action, and then also the main node that starts the robot. So we can uh, we can launch this wall follower.
Mm-hmm.
There are launch file that is the main launch. So first of all, there are start the action server and service, and the robot to find the the wall to follow, and in this way the robot puts the wall on its right and then follow it. Important thing that is uh, that when the robot finish the so the service finish and the robot find the wall to follow,
Mm-hmm.
there are the recording of odometry.
Mm-hmm.
So there are so here we can see the rest of the list, and we have the CMD value, that is the command to robot
Mm-hmm.
for the velocity. So the type of messages is at least,
Mm-hmm.
and then we have the action topics. So the feedback, the feedback it is to with one Hertz. So and then at the end of the recording, so when the robot check the the lap, when robot complete one lap, there are the publish of these topics. So we have a list of others, and also we have the scan, which is the laser scan message, and and we work with it to find the wall and to avoid the obstacles for the central pillar,
Mm-hmm.
and we can see the record on action start. So now
All right. So,
because
tell
the
me
last
something.
is we can, yes.
What I wanted to ask, should it have stopped by now, or
I launched now this ROS topic because the last is I can hear what
right? My question was, it should have stopped by now, correct?
I didn't
Can you hear me, Carlo?
I didn't hear, I didn't understand. So
Okay, okay, okay. But you can hear me, right?
yes, now yes.
Okay. So I was asking you that the robot must have stopped, right? After completing one lap.
Mm, no, he, I understood that the robot, the odometry recording has to stop, but the robot
Okay, okay. So are you saying in your implementation there is no
also
trigger
also the
to stop
robot
the
have
robot?
to, yes.
Yes. So in your implementation, there's no trigger to stop
No,
the robot
no,
on getting to zero.
yes,
All right, all right. So ideally, what we want is we want your robot to know that it has reached the starting position where it initially started and then stop, right? Did you understand that instruction?
okay.
Right. So I want you to explain to me your version of what we meant when you
No,
say,
I understand.
"I color."
I have some trouble to hear you.
Okay.
Sorry,
All right, all right. Give me one sec.
I have some trouble to hear you.
All right, let me see if I can get you to hear me quickly.
The robot reads distance very small, and it confused from the wall or obstacle or cable. I think so. At least didn't happen in the small environment. So
Hmm.
these are the two main challenges when I switch in the real environment. For the red block,
Hmm.
I can show you. Um, I I understand that I differentiate the red block to the wall
Hmm.
using the angle span angle.
Okay.
For example, I set that the angle is um, the 25 degree of span
Hmm.
is of about 15 degree of span is the wall. For
Hmm.
example, I reach this value in try and catch mode, and and the span up to 15 to 45 degree span is a wall, and it is a
Okay.
and also I implement I use the library Lambda communities because I introduced this class for segment,
Hmm.
and in this class I differentiate there are all the maths and to treat the message from laser scan,
Hmm.
and also in this function, for example, I resolve the challenge to the small distance,
Hmm.
and
Okay.
and
So,
then
all right, Carlos. So there's
yeah,
something very interesting, right? I really like the way you differentiated the war from obstacles, and I think let's go back to that, and then you try and explain a bit more, right? For the sake of anyone who might be watching, like the method that you used, I think it's very ingenious, right? Because very few maybe individuals think about it in this way. So maybe repeat a little bit more how you differentiate the wall
yeah.
from the obstacle. Yeah.
So uh, uh, we know that the laser scan um, provide to us provide to us an array of the distance, and then I I understand that in the real environment
Hmm.
there are this red block which is smaller than the wall that the robot has to follow. So I
Correct.
I convert the laser scan array in angle. I
Hmm.
normalize it with this function, and then I check if the span of the laser scan message is below of a certain range. For
Right.
example, I checked with the try and catch mode. So I I try 20 degree of span, and I saw that the robot treats the red block as a wall. So I try 18, then I try 15 understand that is good choice. And the laser scan returns a span of 15 degrees, and this is and in this way I understand that it is the red block. So the robot has to ignore it
Mm-hmm.
the for the for the follow for the follow path. So the robot continue to scan and to search a real wall to a perimeter wall to follow, and
Mm-hmm. Mm-hmm.
which has a span from 15 degree to up to 45.
Right.
I didn't understand. I didn't remember the correct value. And
Mm-hmm.
I also use this I also use this algorithm to understand when there are an obstacle, because in my first implementation of this project, I robot confused a wall also with an obstacle with a signal a signal. So
Mm-hmm.
uh, because sometimes the robot mm, follow the put the obstacle on its right and it turn out it. And
Mm-hmm.
then also in this way, I also uh, differentiate obstacle, small obstacle, from the red block and to wall.
Mm-hmm. Very, very nice. I love the idea. So basically, when you have a wider angle span, right? That thing is considered to be the wall, and the narrower angle span is
Mhm.
an obstacle. Very nice, very nice. So what this
Yes,
bakes into your
yes,
system is like there is an inherent obstacle avoidance in the wall following, which is very, very nice. It's well done. I think well done on that, Carlo.
yes. Because in the simulation environment, I didn't treat this this problem because there is obstacles. So
Mm-hmm.
the obstacles are in the center. Then I understand that I can move it. So and then I I figure out this algorithm, reading something from the university, and I remember it.
Mm-hmm. Very nice. So, other than having to deal with this issue, is there anything else that you struggled with that you want to talk about?
Mm, mm, no, so the main challenge is, as I already said, is to 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 shape the red block. This is
The
my main challenge in this project, and
Yeah.
also as I already said, some small distance and some small distance because maybe it is a chassis reflection of the robot. And for example, in my first fight in real environment,
Mm-hmm.
in my first fight in real environment, the robot uh, didn't move, and I didn't understand why. Then
Mm-hmm.
I put some log information, and I understand that the robot uh, something near to him, and try to go to turn on left and on right, but the robot can't escape from this state. So then I understand that I have to implement a lot more more state for this robot, and I understand that there are some reflection of the chassis, and I
Mm-hmm.
put some value I try some value to correct it.
And which
So this is my yeah.
which part of of the chassis was the one that was giving a closed laser reading, or that was saying there's an obstacle?
So I sorry I hear you uh, bad.
I was saying which part of the robot chassis was triggering an obstacle.
Maybe I think the column on the on, on top of it,
Yes,
maybe,
yes, yes, that's
or
correct.
some or the cable. Okay, okay.
Because the column is
It is the power supplier.
yeah, and it goes above, it goes. beyond the level of the LiDAR scan, right? So it's going to look at that first as the
Yeah.
closest thing. So if you don't filter for those readings, your robot will think I'm about to collide every time. So yeah, very, very well done.
Okay.
And thanks for mentioning it because we think sometimes this is ignored and everyone thinks the robot is not working. It's because of this, right? So very important to also
Yeah.
look at the logs.
Yes.
Okay,
Yes.
so some basic questions, right? I want to understand why did you choose to use a service for your find wall versus something like an action, for example, right? Can you explain and elaborate on that
Okay.
idea?
Because yes, because the service is synchronous and it is a um, is synchronous. So and there aren't feedback. So the the robot has to follow this uh, this service. So the service starts and the robot uh, has to perform this task uh, for this service, and then the service service the robot exit from the service, and but it is different from the action because the action server is something that provides us the feedback. For
Mm,
example, we have 1 month feedback uh, when the main node publish the goal,
mm,
the action server start. We have 1 month feedback for the distance and automatically, and then when the action is performed, so when the action has to stop, the the action also return as a result, as we saw before in ROS topic list. We have the topic from for the feedback, the goal published from the main node, and also for the result. And
mhm.
this,
Okay, so one final question, right? So this is ROS 1, right? So ROS basics in 5 days. Can you explain in broader perspective how ROS 1 is different from ROS 2?
I I didn't so see Rostu before, and
Okay.
but I read something, and I understand that there in Rostu there are some differences in the node maintenance. For example, I read that the node in Rostu are decentralized,
Mm-hmm.
and mm, and then I don't know anything else because I don't study it
Yeah,
for
no worries.
up to
No,
now.
yeah, it's in a, as I said, in broader perspective, I think you have nailed it, right? So they are decentralized, so i.e. there is no ROS core, for example, right? So which is a very important
Okay.
thing for um, individuals to understand. But anyways, thank you very much,
Yeah.
Carlo. Very nice presentation and very nice interactions. So we're gonna wrap it up here, and we'll hang around and we'll finish our conversation once more. All right, everyone. This was Carlos' presentation, and a warm congratulations to him. We'd like to encourage all those of you who want to try this course, ROS Basics in 5 days or ROS 2 Basics in 5 days. You can do that, and then you can come and showcase your work. And until next